This multimedia presentation will give you a clear and simple overview of the hydromechanical and biotechnological Arrowbio process, the most advanced process and cost-effective solution for the treatment of unsorted municipal solid waste. A typical Arrowbio plant is comprised of a number of modules, with each having the capacity to process up to 200 tons of waste daily. Essentially, a basic module has two redundant parallel processing lines, a large pool containing water and naturally occurring microorganisms, two production lines used for waste separation and hydromechanical treatment, and tanks used for biological treatment and storage. This unique system not only recovers recyclable raw materials, such as metals, plastics, and glass, it also processes commercial quantities of fertilizer for agriculture and biogas for energy purposes. The residual waste at the end of these processes is about 3% to 5% of the initial waste weight. The need for Arrowbio has never been greater, as the growing amount of municipal solid waste creates one of the biggest ecological problems of our planet. In spite of widespread understanding of the waste's environmental hazards and treatment costs, there are no proven technologies that address these problems. Landfills, which continue to be the most popular, pollute well water, demand substantial land resources, create a smell nuisance, and contribute to global climate change and the greenhouse effect. Alternative methods, including incinerators, biological treatments, and recycling by manual sorting, to name a few, each have their problems or impractical costs. Arrowbio is neither land-intensive nor labor-intensive, and its biogas derivative is substantially less harmful to the environment and can be used productively. To quantitatively understand this breakthrough, consider that in any large city, this biogas alone can provide all the necessary energy for that city's entire public transportation system. The Arrowbio process is an integrated solution that receives unsorted or sorted municipal solid waste as an input, eliminating the need for prior separation or classification of mixed waste. This waste is delivered by trucks and dumped into a large separation dissolving tank, where bioprocess liquid is already present to assist with the first hydromechanical separation process. Dumping the waste into the bioprocess liquid eliminates the odor nuisance to the environment, and at the same time, the delivery trucks are treated with the same liquid, which thoroughly washes and cleans them of waste products and waste odors. The waste may include non-ferrous metals, glass, plastic, organic matter, ferrous metals, other inorganic materials, paper products, and more. Many of these waste products are in fact raw materials which can be recovered, recycled, and sold at a high market price, generating income for the plant and concurrently decreasing the depletion of Earth's natural resources. In alternative methods, these same elements play a part in several pollution hazards, like global warming from methane pollution, well water poisoning from heavy metals, land destruction from growing landfills, and air pollution from incinerators or other methods. Moreover, since water usually accounts for 1/3 of the waste's entire weight, Arrowbio was designed to utilize this resource to fuel the hydromechanical processes and channels the rest for irrigation and other purposes. This is vastly more efficient than alternative waste treatment methods that either burn or otherwise dry the waste's water content at great energy costs. The preliminary liquid-based waste preparation and separation stage is based on the principle that inorganic materials such as metals and glass have a specific gravity that is greater than water, while plastics and biodegradable organic matter have a specific gravity that is equal to or less than water. Waste from the reception chute is transferred into a dissolving tank, rich with processing liquid, that assists in the preliminary separation, rinsing and cleaning of the waste, eliminates waste odors, and conditions the organic material for the hydromechanical process. The heavy components sink to the bottom of the tank and into a conveyor belt that carries them to a special chamber where heavy fraction separates the various materials from each other and prepares them for recycling. The remaining organic stream is directed via a conveyor belt to the light fraction separation area. The heavy components that sunk to the bottom and were subsequently separated from the organic stream include ferrous metals, non-ferrous metals, glass, and other inert materials. These materials travel down a processing line where a magnetic force is present. The magnet pulls the ferrous metals away from the remaining mass and into a special recycling container. Next in line are the non-ferrous metals, which react to an eddy current system that pulls them away to another collection area. Further down, glass is separated via electro-optical methods or by manual means to be stored for recycling. The remaining materials are returned to the dissolving tank for one last screening, and what finally ends up as residue, usually 3 to 5% of the initial weight, is eventually dumped as inert waste. The recyclable materials are now clean and separated from each other, with a separation accuracy that is greater than that which is achieved by community recycling programs or manual procedures. These materials are now ready to be sold to the recycling market. The light organic waste, already separated from the heavy components, is transported down a chute into a rough shredder and soaked in the liquid to allow maximum absorption of water. Since plastics do not absorb liquid like biodegradable material, they are lighter and can be easily suctioned up and away from the remaining mass and into separate recycling containers. The plastic-free biodegradable material then enters the hydro-crusher system, which disintegrates it down to fiber size, forming a thin slurry. This energy-rich slurry, referred to as biological soup, contains biodegradable material, organic matter, paper, and other substances that can now be treated in the bioreactors to yield fertilizer, water, and biogas. The biological soup now undergoes another 2 processes, both of which are orchestrated by naturally occurring microorganisms. In the first bioreactor tank, acetogenic fermentation transforms complex organic material into simpler organic acids and fatty acids. This acid-rich organic matter is then heated up to 40 degrees Celsius and transported to the methanogenic fermentation reactor for anaerobic degradation of the organic materials and the generation of biomass, water, and biogas. The excess biologically generated water is either sent to the upfront separation tank or channeled to irrigation. The excess biomass is thoroughly stabilized and sold as an environmentally safe agricultural fertilizer. The biogas, composed of 70% methane and 30% CO2, is collected in the upper part of the reactor and can be used as the energy source for the plant itself. The remaining biogas is stored in inflatable buffer tanks and can be sold as clean, green energy for transportation and power plants that is substantially less polluting than alternative fossil fuels. What is more, unlike landfills, emission of methane into the atmosphere is entirely prevented, which reduces the greenhouse effect and global warming and complies with the latest international global climate treaties. Therefore, at the end of the day, Arrowbio is the most environmentally safe, efficient, and cost-effective alternative for the treatment of municipal solid waste. It produces valuable green energy. It recovers raw materials from the waste. It is substantially less expensive to implement and operate, and it requires less land resources than alternative methods. If this is not a win-win scenario, what is?